Arc problem part D. We're referring to this problem, which is in the index of this folder. Same folder as this video. Okay, so we're going to do D. What is the velocity and position of the ball 5 seconds from its launch? We're going to use the same components that we used in the previous problem. Alright, so here's this problem, and we're still going to use these components there, so this is good news for definitely for all of us, right? Okay, so I can just go like this, boop, Betty boop, horizontal, vertical, S-U-V-A-T. And in parts A and B, we figured out these components. These are the initial velocities, so 8.4457 and 40.427 meters per second, right? Okay, and the thing is going to go, we think it's going to go up in the air. In 5 seconds, it's going to be somewhere there because it only stays in the air for, what, 8.42 seconds totally. So 5 seconds is going to catch it on the way down, is my prediction, right? Okay, and now we're all set. It said at 5 seconds, so the time is 5.00 seconds. Acceleration 0. The acceleration or the velocity here doesn't change, and the velocity here will change because there's an acceleration of negative 9.81 meters per second squared. And we got to figure out everything: the velocities and the displacements, right? And this is not hard. Let's find the final velocity here, which is v equals u plus at. Right? So that equals 40.427 plus negative 9.81 times 5, which looks like this in the calculator. There we go. And the velocity is negative 8.623 meters per second. Okay. And people are starting to pound on my door. I think I better pause this. There we are again. So we just figured out the vertical velocity at 5 seconds. So it's on its way down, right? So this thing has gone up and down, right? And it's on its way down. It hasn't been falling for long, less than a second from the top there. And now all we have to do is find the horizontal position and the vertical position, right? Horizontal position is easy. We just use S equals UT, right? So that equals 8.4457 times 5, right? And that looks like this. 8.4457 times 5, right? And so that's 42.2 meters over. Right, and then our elevation, we can find our elevation by using S equals UT plus 1/2 AT squared, right, which looks like this on the calculator. There it is on the calculator, 79.51. Right, so there we go. This is our position. Okay, this thing is 42.2 meters over, and it's 79.5 meters up. Right, that's where we are. And our velocity is, and it says find the velocity in angle magnitude notation. Our velocity is 8.4457 over and this down. So we need to make that into an angle magnitude vector, which looks like this. And this is our 8.623. This is our 8.4457. And we can find a hypotenuse there, and we can find this angle in there. The hypotenuse is going to be the square root of 8.4457 squared plus 8.623 squared, which looks like this in the calculator. There we go. So the hypotenuse there is 12.07 or 12.1 meters per second. Okay. And if somebody said, what is the speed at 5 seconds? This is the speed. This guy here is 12.1 meters per second, right there. Right, and then this angle, we can find the angle. This is the opposite side. This is the adjacent side. And so the angle looks like this. Theta equals tan minus 1 of opposite over adjacent, right? So that equals, this is tan minus 1. It's hard to read there. Tan minus 1, so that's going to be 8.623 over 8.4457. Tan minus 1 of that, right? Which looks like this in the calculator. There we are. 45.59, 45.6 degrees. And that makes sense that this angle is bigger than 45 because this side's longer than this side. Just about 45 though. Okay, so here we have it. We've got our position at 5 seconds is 42.2 over, 79.5 up. Oops, 79.5 up. And then our velocity is, at that instant, it's going over and down like that. And the hypotenuse here is 12.1 meters per second. That's the speed of it, and it's 45.6 degrees below horizontal, like that. That's 45.6 degrees. And there you go.